We recommended using same configuration. They are in the same cluster, right? If they're in the same cluster, we recommend using the same. Yeah, memory is not the worst, but the CPU is the worst. If you have the different CPU, and then it will always use the smallest one. CPU similar, like depend on your concurrency setting. So the less CPU you have on these nodes, the more contention you will have on those less powerful nodes. So that throttle the whole query because the work is distributed to every host. Like Impala currently doesn't distinguish there's different hardware spec on the host. So it pushes. Right. Yeah. Use them. And if there's extra one, you give that to Yarn to Spark. Yeah.
We had this issue in the past, and we configured all the memory, 100 versus 200, pretty much the same use case, but then we had the ones with large memory as being the coordinators.
Okay.
In the proxy, and the other ones did not take.
You. Yeah, coordinator is kind of like exception, especially now we have dedicated coordinator and dedicated executor. So we can separate those two roles. They can have different resource allocation. But generally for executor, they should have the same. Yeah. Yeah. So the second scenario that can use a lot of memory is the Parquet writer. Parquet writer can, since it need to hold all the data first before it doing all the compression to make sure that the final Parquet size is aligned with HDFS, so it kind of pre-allocate some memory to holding the data. So the more Parquet writer you have, the more memory it's gonna use. This is quite common when you're doing the dynamic partition insert, like insert with dynamic partition, that your query can use like huge amount of memory and eventually can go out of memory. So Impala provide like two hints to do that, non-shuffle and shuffle hint for the insert. So you can see the difference. If you don't do shuffle, so every node that it have the data belong to every partition, like a lot of partitions. So average, each nodes can use 4 writers. And after you do the shuffle, since we totally have 8 partition, so we shuffle the data around and each node only write 2 partition. So it has only 2 writers, only need 2 writers here. Then the memory usage can be reduced. So that's because once you shuffle, you group the data together. So each node has less partition. Doesn't mean that they have less amount of data, but less partition to write. So you need a less writer. The more Parquet writer you have, the more memory it uses.
Right. I'm just saying there's an additional step, more networking. So it takes a little longer.
Right. It's more networking and there's a little bit sorting there. That sorting also can use memory. So it's a trade-off. It's not. Yeah. But when you shuffle the data, it's not Parquet yet. It's the real data. Yeah. For the same amount of data, when you use the shuffle, you suppose use less memory. Yeah, because the less writer there. Default is not shuffle. Yeah, you should check if your query run out of memory, your insert query run out of memory. Yeah. What's the underline? It doesn't alter the data. It just move data around. It's shuffle the data. It's move the data from this host to another host to group them. Yeah, it uses exchange nodes. Yeah, if you use the Impala shell, you can just try and explain your insert query by adding the shuffle and remove the shuffle. You can see the plan is different. So the one with shuffle, you can see the extra exchange and a little bit sort nodes there, operator there, to move the data around. Clustered is quite similar as shuffle, but not exactly the same. Cluster is kind of writing the data partition one by one. So after sorting all the data on the each host, it makes sure it only use one writer. So it's quite slow. It compare with shuffle, it might use a little bit less memory, might use more, depending on how expensive the sort is. Yeah, that's true. So another case that can use a lot of memory is if you have a lot of group by. So if your query have a lot of group by, because we need to create the bucket for each group to hold the result, and this number of group is estimated based on the NDV, the number of distinct value for those group column. If you have a large NDV there, the total result bucket needed can be huge. For example, this query we group by 2 columns: product, sold date. So there's 1 million different products, and the table we want to hold the past 5 years data. And the total group will be 1 million times 5 times 365, 1.8 billion bucket. So that's lead to the large memory usage for the aggregation, the group by aggregation. So for this kind of large group by, the way that you can work around it is by kind of split the query per partition. If your data is kind of by partition, split the query per partition to multiple smaller query, and then you union the result together. So this is the only way right now you can work around the group by, gigantic group by. So similar case for the drawing. For the drawing, if you have a lot of partitions, high NDV count, that's a similar case. And the similar solution is you can split the large drawing to multiple small drawing it for a subset of partition, and then union the result together. When we trying to identify performance issue, very important to understand what means reasonable performance, what means worse performance. So those numbers are based on our experiment observation. Roughly for scan, you can get 8 to 10 million rows per core, and the scan can be executed in parallel. Drawing, aggregation, sort, those usually you have just one per node per query. So for the same query on same nodes, there's only one running. You cannot run 2 threads for a drawing. There's only one thread. For the row materialization, for the Parquet writer, is roughly about 1 to 5 million bytes per core. So this is just a rough estimation. Keep that in mind because you're going to need it. When you're doing the performance analysis, no, you can get it later. I'm just so when you're doing the performance analysis, for example, this one, that initially you might think that the aggregate here seems slow because that's the one takes the longest time, 6 seconds. But if you think again, look at it again. So the downstream operator output is 144 million, and you have 3 nodes here. So if you calculate that, you actually get about 8 million rows processed per second. That's actually a normal speed. That's not slow. So when you looking at those number, you should do a little bit calculation to see if it's really slow or not. Yes, per query. Yeah. So there's some kind of a trade-off again. So if you're doing multi-thread, you can make your single query running fast. However, then now if you want to run multiple queries, they will fight for resources. So we're kind of choosing more single thread most of the time because uh, a lot of in reality, a lot of times you're running multiple queries concurrently. So with this single thread, it helps improve your concurrency, make every query moving. Um, for the multi-thread execution, actually since CDH 510, for Parquet format, if you do compute stats, we can actually use multi-thread. There's 4 thread by default. Yeah, so it can help speed up the compute stats. So let's look at this example. So for this one, we can see from the execution summary, the scan is not even. The average compared with the max has some difference. So when there's some difference, you want to find out what caused that. Is it because there's some data skew, or is it because one of the hosts is slower than other? So if you go dig into the profile, you can see the 2 different scan instance. The first one scans almost 3 gigabytes data. So that was 1.7 billion rows. And the second one is just 0.5 billion rows. So it's like 3x difference. So similar here, you can see the data here is also 3 times difference. The second one only scan less than 1 gigabyte of data. So there either could be some data skew here, or could be for some reason one partition has less data than other. That's all possible. So you can just continue exam like what's the real cause and if it was fixed or not. So for this example, we can very easy to see that there's big skew here. So the average is 6 seconds. The maximum is almost 45 seconds. And same thing, let's checking the data we really read for each instance, if there are big difference or not. So by compare the three instance, you can see the range is from like 120 to 150. So the difference is not that big. It's not as the execution time. The execution time is roughly 7x difference, but the execution is even less than like 10-20%. And then you can see that in the row bench queue get waiting time, first one is much slower. So the most of the time compared with others, the most of the time spent is this row bench waiting time. So this is it's a tricky issue. So it can have different costs. It could be because that this host has a slow disk or some bad disk, or it could be that this host has some trouble to connect with name node, because when you read the data initially, you need to access the name node once to open the file. And it could also be that this host, for some reason, have some I/O hotspot, like a lot of query all reading from the same disk, causing that this one has longer waiting time. So although it cannot help you fix it, but at least it gives you some information or what you can do next step. So for this example, the average max is all similar. So at least no skew here this time. But you can see the aggregation here is taking more than 10 seconds. The row it processes is not that big. And based on another scan nodes, you can see that the cluster have at least 22 nodes. It's not just have 2 nodes. So why does it only use 2 nodes for aggregation? So we can examine the plan first to see if the plan is reasonable or not. Why does it choose the parallel 2? So in the plan, you can see here the partition. After the partition pruning, there are only 2 files. Since there's 2 files, so for Parquet, like by default, we only use 1 node per file. So that causes the parallelism is too low. Only 2 hosts used to doing the aggregation. So for this case, that you can go with different solution. If it's possible, you can consider like using smaller block size so that the data can be spread on more nodes to increase the parallelism. Okay, so last example. This one is a quite tricky one. So this query is very slow here. So we examine all the metrics and we don't see any significant skew, or the only thing we notice is all the network related metrics seems like quite large compared with other metrics. And the bytes we send here is about 2 gigabytes. 2 gigabytes is not small, but if you compare with the time it spent, it probably not that significant because it takes roughly half an hour to sending 2 gigabytes. So this kind of indicating the network or somewhere network related issues. Too slow, the network might be too slow. If you want to dig deeper about the network metrics, you should check exchange nodes and the data stream sender. Since the exchange is kind of like in the middle between the 2 hosts, you're sending data from one and another host receive it. So the matrix is split between the receiver side and the sender side. The data stream sender is the sender side, and the exchange is the receiver side. So from here, you can check if the problem is at the sending or at the receiving. Kind of can keep digging what's the possible issues here. So the network slowness can be caused by different reasons. Most common one is if you don't have stats and then planner choose the wrong plan, like broadcast a large table or run join order, put the large table on the right side, all those kind of case. And similar, the large number of group by, or and if you in your query, if you are not careful enough, you just simply put the select start there, then it will sending the whole row instead of just the column you need. So all those that can trigger a lot of network traffic and cause network slowdown. So even though you can expand your cluster, but your network usually is fixed bandwidth. It doesn't expand as fast as your node size or whatever. And the cross-rack network is also even lower at the fixed bandwidth. So those are much harder to identify. This is like roughly the end of all the examples. So do you guys interested in work through more profile, or you're had enough today just for questions? Yeah. Yeah. we do have some metrics. So let me show you quickly. So you can see here, this is a dashboard. Actually, I just create myself for myself to monitor the workload. What I'm care about is first, if in general the system load is high or low. So that's the system load here. So you can see that metrics from the host, I think from the host chart map, you can find that one. I could share it. Let me check with them if I can just upload any kind of file into the dashboard. If yes, I can upload. Yeah. So yeah. This is load average. So this is load average. I'm just listing the 1 minutes there. By default, you have load average for 1 minute, 5 minutes, 15 minutes. So if you're seeing that your load average 1 minute is higher than the 5 or 10 minutes, 15 minutes, which means that your system load is increasing. So either that you have more workload coming in, or you have maybe some hardware issue, whatever issues there. So that's the first thing I'm looking at, if the system load is high or not. If the system load is not high, then which should means that all the resource, you have enough resource there, you don't have any resource intention. But if the system load is high, then that can have some indication about either your memory resource, your CPU resource, your network, your disk could be one of them. They're kind of being used, a lot of usage there and have contention. Then you can examine each of them. Like you can check the memory, the Impala service CPU, the host swap to see the disk swap. Sorry, this should be disk swap. If there's a disk swap, disk state, if they're significant, and the host network. So you check individual resource, each one of them, if there's anyone in the contention. And if there's contention, then you can, for this one, since I'm listing it per host, depending on how many hosts you have in your cluster, you can just show them for individual one. So this way you can easily see if there's any outlier or if every host has a similar amount of workload. So in my case, it seems not bad. Like most of them, at least at the CPU level, it's not big difference. But currently this cluster is idle, so it doesn't have any workload. Just for example, this one, you can see there's a small spike here. So that can indicate that for this host, there's some load happening on this one. This is the CM host. So it's possible that there's a name node GC or there's whatever name node related activity and then cause some slowness. That's possible. And beside the general at the system level, if you are have suspect that it might because of your query workload, you can monitor the query completed query. So this one kind of can map to the query throughput. By default, I think we do the query QPS, query per seconds. So for myself, I feel that most of the time that granularity is too hard to read. So it's each query can usually at least take a couple of seconds. So I change that one rate to like per minute. So that will be more reasonable result. Let me actually just run some query. Maybe you can see. So yeah, we should be able to see some usage here after when I run the query. So you can see here, now the CPU, the fragment here, you can see the difference. So the fragment per minute, that's also the in-flight fragments. That can give you idea right now what's the workload on the Impala service. The query per minute can give you some idea, but if your query, each query is very complex, So the number of query in term of the workload is not one-to-one mapping. If you have two very complex query, then the system load can be much higher than just the 10 very small query. So you better check the fragment rate per minute. That can give you idea like um, more real that how much workload in the system. Yeah. So this is still kind of like high level monitoring, resource monitoring, workload monitoring. If you're do you need any specific kind of metrics you're looking for? Or?
No, this is good. Let's take it a high level.
Mm-hmm. So okay, but that one actually you can get it here already. If you go to the query history,
I can get it here. What I need help is
okay,
that's really what I was trying to do. I can do it.
okay,
I like this reputation.
I see. Okay.
Like here, you just get the three.
Mm-hmm. Yeah. Okay. I see.
That should be easy.
Okay. Yeah.
Maybe a nice blog post, several queries, depending on what you're trying to do.
Right. Yeah. Yeah. Actually, I'm thinking about like create a blog post to explain how to use the CM chart to help you monitor the workload, the service, find the bottleneck. Yeah. Yeah. So which one? You mean this dashboard? Top X about which user execute most of query? Is that?
It depends. I mean, I think you would take a lot of these suggestions that you go through and describe,
Uh-huh.
and then you would try to derive those to be able to work identify as opposed to search it really deep query by query. Have the ability to go out there insightfully and determine, hey, here's query that needs to be done. Or everyone is thinking a lot of money.
I see.
You know, you should have the ability to have the
So we actually have you ever heard the Khedira optimizer?
I have, but that was part of the software with my query.
Oh, okay. So you want
I have 2,000 queries, I can't do that.
I see.
So how do I do it without that
Unfortunately, no. Right now, we don't have that integrated to this to the CM. So yeah, if I want to optimize query, like for me, I'll probably just go to the history page and finding which one use most of memory, most memory or longest time that way to see if it can be optimized. Because if you okay. So we are working on something. I cannot give too much detail, but we are working on something to help people optimize workload. It will based on your query history. We analyze it and finding out like what's the top problem on your cluster. Is it a small file? Is it metadata? Is it like too frequent refresh? Or is it some, yeah, yeah, we are working on something. Yes. Yeah, if you are interested, but maybe you can talk to me. Yes, it will. Yeah, yeah. You can talk. We can talk offline about that, and yeah, we can see. Well, I can. I'm not working on that, but I can connect you to the team who's working. It probably gonna come pretty soon. It's a separate thing. It's not in the CM. It's not the Impala release. No. I think the final goal is probably can combine all the optimization, all the guideline together, but it will need to be done step by step. I think the first step is just to identify where the system's bottleneck, what's the top issues there. Yeah.
In the meantime, it would be really nice if the query space, if one of the metrics was the number of files.
Okay.
So often that is the driver for why
Yes. Yeah.
if we could just say, show me
Yeah.
the number of files that were read.
Yeah. Um, I think in on the Impala side, we also trying to adding more and more improvement to help people to fix those metadata related issue. So in I think should be in the next release. So we have some metadata improvement that will tell you this table, how many files you have, what's the average size. So tell you that this table has too many small files. Yeah. Yeah, we will have kind of like a top list, which one has the largest metadata, and then you can drill down to see if it's caused by incremental stats or if it's caused by number of small files, and then you can address it. And yes, it actually small files is a problem for a lot of service. Mhm. Yeah. Mhm. Yeah. 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 Exactly. Mhm. Yes. I agree. Yes. Yeah. Yes. Yeah. 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 Definitely. Yeah. But I I would say that I think a lot of customer, even though we point them out that you have small files issue, but they just don't change it until they really hate it. Mhm. Yeah, I've seen people like using time step as a partition. Yeah. Okay, I think we are out of time. So one more thing I like to mention is I'm also holding a brain date, what they called tomorrow. That one. Well, I'll talk about how to scale Impala. There's still a couple of spots available. If anyone's interested, you can register for it. 3 p.m. 3 p.m. It's not a talk. They call it brain date. Yeah, brain date. You can go look for it, and if you're yeah, I'm going to talk about because for this one, it's focused on like performance troubleshooting. We don't have much time to talk about the skill. So tomorrow, I'm going to discuss. It's more like just a discussion. It's not going to be a formal presentation or something, but I can go over some common scalability issues and how to address them. Yeah. Yeah, it's 3 o'clock. You can just go to the brain data and search for the how to scale Impala. You can find it if you're interested. Okay, thanks, everyone. Yeah. You need to register. I think they have a limited spot. I don't know why that even for group, I think they only give 4 spots. I can ask if they can lose that limitation, risk constraint or something. Yeah. Okay. You can.